let's get into topic 1.4 on permutations. So permutations is choosing, let's just say, a number of people from a bigger group of people to fill specific roles. So basically it's choosing a small number from a bigger number, and each of these numbers is going to have a specific role. That's what basic permutation problems involve. So how do we approach these problems? Basically, when you first get a permutation problem, let's just say there's people and you're electing a president and a vice president out of a group of people. Let's just say there's 50 people in this group. So there's one person, two person, and you dot, dot, dot. And in total, let's just say there's 50 people here. And you have to pick a president and a VP. So out of the 50 people, there's obviously 50 people that can be president. So there's 50 choices. And then out of the VP, there's 49 choices because everyone but the president can become VP as well. So in total, there's 50 times 49 equals 24 50 choices to pick two people. So when we're permutating, this is what it's called, 50 people, and we're choosing two of them to fill specific roles, the answer is 2450. And the way we got this was we did 50 times 49. Now, if you notice 50 times 49, what is that really similar to? It is equivalent to 50 factorial over 48 factorial, where factorial means you simply multiply down to 1. So, for example, 6 factorial would equal to 6 times 5 times 4 times 3 times 2 times 1. So 50 factorial over 48 factorial would be the same as 50 times 49, since 50 factorial is just 48 factorial times 49 times 50. Now, this way we can derive a generalized formula. Why? Because you realize 50 factorial is simply the number of people. So in a case where it's n people and you have to choose a of them, 50 factorial n would be at the top, it's n, and then 48, what is that number equal to? It's equal to n minus a. So that is a generalized formula for permutations. So in order to choose a group of a people to fill specific roles out of a group of n total people, there's n factorial over n minus a factorial ways to do it. Now we'll put this into practice. So we'll be looking at question 1.16. My city is running a lottery, and in the lottery there's 25 lottery balls, and 4 balls are drawn one at a time, and the winning combination consists of the 4 selected balls in the order they're selected. So how many winning combinations are there if each ball is discarded after it's removed and each ball is replaced from the bin after it's removed before the next ball is drawn? So first, if each ball is discarded after it's removed after the first ball, there's 25 choices. So it's 25, choose 4. Or not choose 4, permutating 25 to 4. And this would equal to 25 factorial over 21 factorial. Now, that would equal to, if we do some calculations, 25 times 24 times 23 times 22, this equals to 303,600. However, if you replace in the bin, there's 25 ways to pick the first ball, there's 25 ways to pick the second ball, there's 25 ways to pick the third ball, and there's 25 ways to pick the fourth ball. So remember, when there's replacement, the permutation formula does not hold. Instead, it's just the number of things you're choosing, that's the power, and it's just simply n to the a. This only happens if there's no replacement. And in this case, 25 to the 4 is 390,625. Again, you can see if you replace it, it's higher because there's more balls in the drawing at any given time. So that's what we get. So for homework today, I just want to task you guys with a really simple problem. So let's say there is a group of 50 people and we have to choose between them an officer, a president, a VP, a chairman, an HR, a marketing, and one salesperson. So there's one of each of these roles. And obviously each one of them can only be filled with one person, and there's no overlap. So in total, I'll count it for you. There's 7. So 50 permutating 7. Just calculate that, drop it down below, and we'll let you know in the next class if your answer is correct. Thank you.